All right, let's get started. So tonight, visualizing multiplication and division by powers of 10, we've got Sarah Schaefer. Sarah is the founder of Methodology. Methodology's mission or exists to help teachers, students, and parents make that connection between the why and the how within the field or the world of mathematics. She's been in classrooms conducting learning institutes across America, probably internationally, but I'll let her talk about that. She's the lead author of Think Mathematics, which is grades 1 through 5, and Developing Roots, which is a pre-K through kindergarten program. And she's been teaching K through 12 mathematics in public and private schools since 1995. So, two things I can tell you about Sarah, and I think it'll be obvious about her passion for what she does and teaching of mathematics. But the other thing I know you'll notice is Sarah has this wonderful capability of making the complex or the complicated very simple. And I really admire that. So with that, I'm going to stop sharing and I am going to let Sarah take over. So thank you, Sarah, and it's all yours.
All right. Thanks for that, Mark. I'm just looking. Can you confirm at the bottom of my Zoom it no longer allows? Oh, there it is. Couldn't see the share. So thanks for that. Super excited. As Mark said, you learn by doing in my world. And so if you're here to listen, great. But I would love, you're going to get more out of this if you participate. Um, and the main big ideas you can apply to pretty much any of the operations in teaching mathematics well. Tonight, our focus is going to be on multiplying and dividing with a focus on powers of 10. And really why this came to be for me is that I listened to a webinar from John Vanderwall in his book, The Teaching. Can you guys see my screen all right?
Yes.
Yes, we can.
Awesome. The learning and teaching of elementary mathematics. And in his webinar, he talked about this idea of putting on zeros and moving decimal points and all this stuff. And how kids really just have no clue what's going on when we're doing that. And so I figured this is a great topic because the standard in fourth and fifth grade is one that I think teachers are afraid to teach or students just don't grasp well. So that's why I chose tonight's topic. So hopefully by connecting the pieces with the visual models and the abstract, we're going to see how kids can come to learn this topic better. So getting started, multiplication and division powers of 10. In the chat, go ahead and enter. What are some of the foundational skills do you think that are needed in order to really teach this topic? Go ahead and add, I see place value sense, patterning, times tables. So a lot of place values coming up. Part whole, skip counting. Yeah. All right. So in looking at that, first off, we have to make sure they know the meaning of the operation because we're going to tap into what does multiplication and division mean. A big idea is we want number sense and having kids, is our quotient or is our product going to be a lot greater than what we started with, a lot less than what we started with. So we need to know the meanings of multiplication and division. We really need to understand this idea of 10 becomes 1 in both directions and what that means. And tonight, if you leave with nothing more, I want you to think about, is the decimal point really moving? It's not the decimal point that's moving, and we've got to get away from that. The decimal point is staying, and it's the digits that are moving in order to get this idea of scaling. So tonight, I'm really going to focus on that decimal point, and we're going to look at the idea of scaling when we're talking about multiplication and that digit as well. So just a few quotes. This comes from Vanderwall, Karp and Bay Williams' book, is that when students are just told to move the decimal point in the answer, the idea of scaling, we don't have a visual model of what it means to be 10 times greater or 1/10 of the value. And so if we're talking about this idea, we need, again, that visual model. I've just attached here, I know we have a lot of international people on the call tonight. Our fourth grade standard in the US requires that kids or students recognize that in a multi-digit whole number, a digit in one place represents 10 times what it is to the place to its right. And that the wording of that is really difficult for kids. And so tonight, our objective is to see what that actually means again, using visual models. And as we move to fifth grade, it goes to the left here, and that it's 1/10 of what it represents to the left versus to the right. And in fifth grade, we begin to look at the number of zeros and what happens when we work with the powers of 10. So tonight we're going to really focus in that fourth and fifth grade realm and tying in the foundations that were laid in the beginning, multiplication and division, and that would come in the third grade. All right, so I want you to go ahead and let's enter that first share code. And the task is this. If I have, I'm going to go ahead and pull up the base 10 blocks. And if I'm looking at relationships, I see in the chat there, you know, we're talking about patterns. Before we start with powers of 10, talk to me about the relationship visually. What can we say about the number 2 versus the number 20? What do you think, kids, when we're looking at that relationship, what would that mean? And I'm gonna, that share code, Mark, if you can enter it, is that one that starts with the BVKD? All right, there it goes. And you can, it just is giving you the screen basically here with this idea of 2 and 20. Yeah, I see an additive relationship. So students might say, you know, the blue is 18 more. So 20 is 18 more than 2. All right, what else do you see? What else do you notice? All right, Liz, thanks for that. So 20 is 10 times as much. And I want you to think with this visual model, how are we going to show, you know, that idea of 10 times as much? And so if I rotate here, we can see, well, we have 1, and you can count 2, 3, 4, 5. And then if we continue to count there, we can see that we have a relationship of 2 versus 20, and we get a visual model of what it means. We can also see that if this is considered, you know, 1, that if this is considered 1 whole, that this is 1/10 of that, because 10 of these make up that 1. So we're starting to get this multiplicative relationship there. And we want to always connect. The math is a language. In any language, in order to become fluent in a language, we have to be able to speak it. What does it mean to be 10 times as much? What does it mean to be 1/10 the value of? What do we see? We see one group of 2. How could we build that? And then how can we capitalize and write that relationship? So visualization is an overarching idea that I do a lot of work with this Singapore-based approach, in that CPA. You've heard CRA, you've heard CPA, but you're looking at the idea of how many times that comparative relationship, which is taught as one of the meanings of multiplication. And we can communicate that here in looking at what that means. So we have, what does it mean to be 10 times the value? And we can use symbols. We can use symbols to show 10 times that value and 2 tens. And then what does symbolically that mean in that relationship? So as students are communicating this math as a language, I see 2, I see 20, I see 2 tens, I see 2 times or 10 times that amount. We want to get that in so that they're connecting this symbolic language with 10 times with the verbal language that we're seeing in that standard. And I see people putting in there the idea of cents, the dime, or 2 cents versus 20 cents in that relationship as well. Well, we got to take this further and look at that idea of pattern. So now we're starting to focus more on the digit and what's happening here when we write this maybe in a place value chart. What do you see? What do you notice? What's happening? We have that digit 2. The 2 is moved. Okay, so as the 2 gets 10 times larger, we're starting to see the digit has moved. The digit has shifted. And so we're making a conjecture here that when we multiply by 10, we're noticing something happening to the digit. All right. So that digit has moved to the left there, and it's gotten 10 times larger. All right, so we're going to capitalize on this powers of 10 of using basically what they know before we get into actually our exploration today. If this idea continues, let's go to that next share code, the one that starts with a GCW, please mark there. And what is the relationship going to be now? And how could we describe it in words and in symbols between 2 and 200? Right, so take a minute and we looked at it between 2 and 10. What can we say? What could we write? And now what are we noticing about the digits? And so I see somebody saying that it's 100 times. Could you prove? And yeah, we could prove, we could count 1, 2, 3, 4, 5. And if we continued across 6, 7, 8, 9, 10. So in one of these rows here, we can say that it's 10 times larger. We already knew that. And then we can say 20, 30, 40, and we can see that in 100 groups, we have 100 groups of 2. So now how are we going to write that? Okay, so 2, we have one group of 2. And then we can see, well, what's happening here is that when we multiplied by 10, what happened? And then when we come from here to here, we can see what has happened as we multiply. And so the question came up, is the digit moving or is the decimal? So there's my question for you. Right now, where is the decimal point? The decimal point, by definition, defines the units or the ones place. So the decimal point, and usually in a calculator, you're not going to see that decimal point with whole numbers because we know where the ones place is. So the decimal point, we typically don't even write it here. is used to identify or define the units place is always to the left of the decimal place. So we have here, we're noticing our patterns of 2 times the relationship. Again, we're looking for that pattern between 2 and 100, is that we can show that 2 times 100, 200 is 100 times greater. And this digit shifted 2 places as we multiplied by 100. Again, the decimal did not move. The decimal's still there. The digit is changing. So before we get into powers of 10 with decimals, we have to really make sure with whole numbers. And I took it back to 2 and 20 or 2 and 200. We could take it to 1 and 10, 1 and 100 to really understand what this 10 times greater or 1/10 the value of actually means. And so I just want to pause before we jump into a problem where we're going to explore to answer any questions you might have on something that I've said. I'm checking the chat as we go along around this idea of math as a language, the idea of patterns and relationships. Yeah, so the blocks are great. I'm seeing that. I like to use the base 10 blocks as well. As we get into decimals here a little bit, I move more towards the decimal disc. But when do I use base 10 versus place value disc? When I want them to see the 10-ness in it and actually physically move and count it. Because I find with coins and with place value discs, you don't see that magnitude as much. You can break it apart, but a tens disc looks the same size as a hundreds disc, as a ones disc. So I like to get that one-to-one correspondence there as well. All right, so let's go ahead and move on to our first task, where I'm going to have you explore a little bit. And in our program, we always start a task with an exploration. And I grabbed a grade 5 exploration here. It's from the SL Education Think Mathematics books. And in this task, I'll just give you a minute to read the task so that we have a gist of what's going on. So we're given the mass of a giant panda cub. And in the US, usually we don't record the weights of something in grams, our weights. We usually look in our in pounds. But in this task, we're given the weight of a panda bear, a cub, at 1 day, at 1 month, at 3 months, and at 1 year. And it's hard to make sense of or even compare this to something in our own world, like to even get a sense of what that feels like, that mass might be. And our friend here, Hazel, is telling us that giant pandas are fully mature when they get to 4 to 6 years. And so I've taken this table, and I'd like us to try to figure out how visually, right? Because we're trying to connect this idea of powers to 10 in relationship to visual models. And so I'm thinking of this 1 in 5/10 times 2 to the second power. And we're going to take a share code here where I've presented the 1 and the 5/10. So in your Brainingcamp app, you can go ahead and that share code that we're going to add here is going to be the JL9P 8, and I'm sure they've already got it in 8B9 NA. So go ahead and, oops, you can see that I've shown what 1.5, just to save some time, 1 5/10 that is, times 10. So we know the meaning of multiplication. We know the meaning that we can take this and it's 10 times the value of. So I'm wondering now if you can think of, this is the visual language for this, right? How are we going to now connect that visual language to make sense of this? And so I just want to give you a minute to play a little bit with this in trying to understand what the value of this is and how to give a visual model for this idea of magnitude. And so when I think about this, and I know as a teacher, my goal is to get them to say, okay, well, how might I be able to even find out what 10 times is? So Kristen, thanks for adding that there. 10 times this group, right? So I could count, that's one method, right? I could think about this as, okay, well, what is 10 groups of one? And I can see that, whoops, sorry about that. I can see that right here. We can see that 10 groups of one there. And then what about this? You know, I have this half. And what does it mean to take a half 10 times? And so some students might say, well, you know, a half 10 times. Well, a half here we can see we get 1, 2, 3, 4, 5. You know, that 5/10 there. And then we can continue and see that, okay, well, what happened here? Well, when we had one group, we have this. All right. Well, when we have 10 groups, what happens? Well, the 10 groups of 1 gives us the 1. And then we have the 10 groups of a half. And what does that give us? That gives us I'm sorry, 10 groups of 1 is 10. And 10 groups of a half is 5. And when we combine those, we can say then that 10 times that value is 15. So let's go back. Did the 1 become 10 times larger? Did that digit, it moved from the 1 to the 10s? We can imagine that digit moving, and then that 5/10. So if we think about that grid and decomposing that number, decomposing the number is the distributive property. It's just a childlike way to saying, okay, I'm going to break it apart, multiply them, and then put them back together. So sometimes we use a more childlike way to show that. And maybe sometimes we use a more formal way to show that. So as we're talking about looking at this and visualizing it, we can even use like a problem string where we could say, okay, well, if we know 1 times it, could we imagine what 2 groups of it would be? 4 groups, 5 groups, and eventually getting to this idea of, well, 10 groups. Formalizing the language and connecting. Okay, so 10 times the amount. Well, we get the 10. Can everybody see where the 10's coming from? And where's the 5 coming from? All right, but that wasn't the question. The question was, what's 100 times it? So if we knew that 10 times it, and 10 times it is here, was what? That was that 15. So now what are we thinking? Yeah, we could think of, okay, well, now we have 15 times 10. Yeah, and this goes back to place value, which you guys hit on. Some people, 15, this is the symbol that we use for the word tens. 15 groups of 10 is the same as 15 tens. That's all it is. 15 tens. So let's go ahead and put that in that chart. So this is what we came up with. We saw that we started with one group. Okay, here's our one group. And then we said, well, with multiplication, remember, we have to know what multiplication means, the meaning. Okay, so we can take that 10 times. We could count. I heard people say, or we could decompose distributive property to come up that 10 times is going to give us the 15. So we started with the 1 times the 15. And now, so let's go back to our conjecture. Did the digit or did the decimal point move? The decimal point hasn't moved, guys. It's still there. So when we multiplied, the 1 got 10 times greater. The 5/10 got 10 times greater. And then what happened when we got here? So we're starting to see that, yes, as we multiply by a power of 10, the digit 1 is becoming 100 times larger. And so is the digit in that tens place, giving us the value of 150. So whether the language, I was that teacher in 5th and 6th grade, and even in high school, talking about moving that digit. And until I heard that John Vanderwall episode or podcast, it really made me think about my language and what's happening and what the definition and role of that decimal point is in defining the units place, and then using that to look at how the digits are moving because the quantity is getting larger. So we're seeing the scalability, right? So we scaled this up by a factor of 10, and so then we can say 10 times greater will give us this value. So we're seeing that yes, the quantities are becoming greater. And when they become greater, it's forcing that relationship, or we're seeing that relationship to generalize a pattern. Because we don't want to build this forever, right? Especially as these numbers get bigger. So in this task now, we figured out at the birth of did you know that at the birth, the cub weighs 150 grams? And so I'm wondering, 150 grams, did you know that's in the US, if you thought about it, a gram, I like to think of a gram like a paper clip, about 1/3 of a pound. So trying to make sense of one, not only what's happening when we're multiplying by these powers of 10 visually, but what does that mean in the context of the problem? And so tonight we don't have a chance to get in and look at the other quantities that were given in that original task. But I think what's important for us in looking at the multiplication is not jumping too quickly to a rule, but having them build it, the concrete or the pictorial with the visual models, connecting that model to the symbolic, what just happened symbolically, and then looking for the place value and what's happening. And so we can see at the different time periods what was happening with the mass of that panda bear, and just gives us some context. And then we could come back And I thought it was really interesting. At 1 year old, the actual weight or the mass of it is probably typical to what a fifth grader, the average, if there is such a thing, average fifth grader might weigh. So they could say, okay, when they look at that panda at a year old, they can kind of imagine what that might be. So in our task there with multiplying, the goal for us was, for me, with you, is how do we support something that a standard or a rule that talks about just moving digits, starting scaffolding it with something that we know, 2 versus 10. That's pretty attainable. We could visualize that, and some of you put money as well. And then how could we use manipulatives to, as we grow it, and what does 10 times look like? And then what does 100 times that look like? So we can see that, that scalability there. Any questions on multiplication visual models? With multiplication, if we go back to foundational ideas, we have to know what multiplication means, or we can't build it. We have to be able to flexibly decompose with place value. Yeah, context. I think it, and we know that good math practice tells us that we don't give naked numbers. That's something I really value about the curriculum we use, is that all of the tasks are built around some kind of context, and then bringing it back to the their own lives, because really, like, do they know what a gram, a pound? But they can look at themselves and kind of relate it there. John Vanderwall, and the name of the book, I'll bring it back here. Hopefully you're not getting sick from me swiping through here. John unfortunately passed away, but John Vanderwall, and this is the book. This is a great book. If you don't own this book, you need to get it. It's fabulous. Actually, it's the book when I went to study in Singapore that my colleague, Dr. Yap Banhar, used in his classes that I used. All right, division. So let's go back to this idea. Place value. Any kind of table, whenever we're looking for patterns, I go back to tables. And it's got to come from the students. And so think about when you put numbers into your charts. How are you writing them into your chart so that they can see those relationships? And then they're going to use, as Piaget would say, they're going to use their childlike language. And then we just scaffold it on. So they might say, well, that 3 moved all the way over there. Well, let's count how many places did it move. And then, oh, so it was times 10, times 100, times 1,000, times 10,000. So how could we write that with symbols? So we've got to take their childlike language and add more adult-like language to it, and symbolic language to it. All right. So another task we have here, this is, I love, again, money problems. Excuse me. Take a minute and read our task. This is our friend Carlos. We have different characters that grow up with this series, so the students know Carlos. And Carlos, as you can see, he saves an amount of money every day. And he saves the same amount of money every day. And after 100 days, he has $125 in his coin bank. I'm wondering if you could take this task, and I want you to think again from a teacher's lens. We're talking about dividing by powers of 10. But how can we use this task How can we use visual models? How can we use place value charts or tables to help them see patterns and communicate this language? So I'm going to put that share code in, or Mark, if you could put that last share code, the F5F1. And in this task, before you get started with it, you can look at the task. I want to just review something that I've come to realize in 4th and 5th grade classrooms and working with schools, is that our students don't really understand the meaning of division. All right, so first let's talk about prerequisites. In this situation, I need them to know that there's different meanings. We have the measurement meaning of division. And so with that measurement meaning, we can go ahead and see that. I'll just grab some linking cubes here. And in that picture, I've kind of demonstrated it. We can say, okay, well, in 6, okay, so if we just take something they know, in 6, how many 2s? Okay, this in 6, we can see that there's 1, 2, 3 2s. So that's that idea of how many 2s fit in. We can also say that 6 divided by into two groups. And so we could say, okay, 1 there, 1 there, 1 there, 1 there, 1 there, and 1 there. And we could talk about that partitive meaning, the idea, right? So students should have this as prerequisite knowledge, just like they should have prerequisite knowledge of the concept of multiplication. We may want to scaffold it. We may want to come back to something that's a little bit easier first. So in 100, how many 10s? And so visually they could count and they could see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so then in 100, how many hundreds? So scaffold it back and record it and maybe put it in a chart. What are we noticing that's happening before we jump into our task here? Okay, so if we have that chart and we started with 100, and here's the decimal point, and when we divided by 10, we got this. And then when we divided by another 10 or 100, we got this. And so students are going to start to talk about, again, that what's happening. It looks like that digit 1 is becoming 1/10 the value of, and it's kind of sliding over, right? The digit moving over to that. All right, so we need to know meaning of division, how many fit in so we can actually do the task. And then we've always been looking for patterns. That's what math is about. It's about looking for patterns and generalizing those patterns. All right, so now let's go ahead and take a stab at this one. I set up the board like this because I needed the decimal discs to be there. And so we have 125, and we're just going to look at it like this. I saw somebody put in there, maybe it's a different currency, so you could change your task. The big idea for the task is that just you're dividing by 100. So whatever amount you're using in your currency, it's dividing by 100. Maybe first think about, is it friendly to divide the 100 by 100? Okay. What about the 2 10s, the 20, or the 5 1s? And if not, Could we use a simpler problem? Could we divide it by 10 and then divide by 10 again? And I like how I see some comments in there. Jen has said, do you think, let's just go back to that meaning, just to, if you had to estimate, right? Do you think in this problem, your quotient, if you're trying to break it into, first off, is this partitive or is this a measurement meaning with the context given? Yeah, we're looking at each day. So we're looking at the groups. So we're trying to put this, is it going to be friendly to put that into 100 groups? How about this? How about this? All right. So if we're going to break up 100 into 100 groups, is our quotient going to be greater than what we started with or less than? A lot more, little more, a lot less, little less. So just getting some ideas of estimating, but let's go ahead and look at that. I'm seeing some questions about share code. So if you just come to your share code, we can share the share codes after. Why and when do I use share codes? When I either want a certain task for kids already ready to go. So I didn't want you guys to have to build it and lose time that way. Or if there's a lot to build. So I in particular wanted you to have all the same screen here. And so our question is it going to be friendly to divide this? How might we want to start? In the chat. We know that visual models are super important. So as a teacher, what's our first move if this is where we need to get them to? Oh, okay. So somebody's saying, let's deal with the 100 first. Let's not worry about the 25. Let's leave that because we know that this amount here, 100, that we could share it. Okay. And so again, we'd have to, because right now we could easily see the 10 groups, but this is saying we need 100 groups. So can you imagine? So what is 100 put into 10 groups? Yeah, we can see that there would be 10 in each group, right? And so if we took that 10 and now this went into 10 more groups. That's right. So we could see, and we could even break that apart to see, and the screen would get really busy right now, but we could see that 100 ones and that we would have one in each group representing one each day. So we all agree that that 100 is going to be really friendly. All right. So what are we going to do with the 25? Any ideas? Go ahead, put it in the chat. All right, 20. All right, so I can see 20. If I want to break this into my ones, I can go ahead and see, okay, well, if I put it into 10 groups, I could get one group, 3, 4, 5, 6, 7, 8, 9, 10. So 20 put into 10 groups will give me 2 in each group, but 20 put into 100 groups. Yeah, that's right. Well, how am I going to take these two right here, and how am I going to move and put them into 10 groups? Yeah, I have to break that apart, and I could think of it now as 20 what? What do we have here? Yeah, so if each one of these is put into, we've got 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, 8 group, 9 group. Did I count wrong there? 1, 2, 3, 4, 5. Yeah, okay, we've got 10 groups. So just this part, I'm going to say in each group we have this amount, but we've got 10 of those groups. Yeah, so we have to decompose that. So as we move through this, it's getting really crowded here. Can we start to look at what was happening when we took and divided by 10? When we took that 100 and we put it into 10 groups, we got, yeah, 10 in each group. And then when we took that 100 and we put it into 100 groups, we've got 1 in each group. And then that 2, what happened to that 2? When we took that 2 and we put it into that 20, those 2 tens, and we put those 2 tens into 10 groups, we got 2 in each group. Okay, we got 2 in each group. So when we took the 2 tens and we put it into 10 group, we got 2 in each group. And then that 5, what happened to it? And so what kind of patterns are we noticing here? Allison, thanks for jumping in there. You're noticing that the language we could use is we could say we're dividing by 10, or we're multiplying, it's 1/10 of the value. We're multiplying by that 10th. So each one becomes 1/10. So 220 becomes 2 1/10ths. That's right. And then the 5 ones become 5. And so again, we come back to the main ideas here is that when we had $125 and we needed to share them equally, maybe starting with 100 days, what if I collected it over 10 days, what would it look like? And then how with place value do we decompose it? Will the 100 be friendly? Will the 20 be friendly? And will the 5 be friendly? And if so, go do it. And some students will be able to see that when we do 125 divided by, we're going to get $12.50. And then because we have context, we can now say what? That if I saved 125 days for 10 days, the same amount, that means, what does this quotient represent? I saved $12.50 a day. All right, well, what if I broke that up into 100 days? What's that relationship look like? And now we can see. All right, we put it back into the table and we see, did the decimal point move? The decimal point did not move. The digit, as we divide by 10, the value of the digit is becoming 1/10. As we divide by 100, the value of the digit is becoming 1/100. Well, how could we do that quickly then? We would think about or visualize that table and then visualize the sliding and then verbalizing that that digit sliding. So the table tool, somebody asked about the table tool. I see that in the chat as well. I have used the table tool as well. So I'll bring that up for those that aren't familiar with it. Let me get a little bit off. Move some stuff around. I'll bring it over here. You can, you can type in here with your labels and you can expand it. So you can insert that. Where this is kind of going a little bit off tonight, but actually I could probably do it right now. If you wanted to see, for example, get some practice here, and say we were dealing with a 3-digit number. So I'm going to expand my table a little bit here. I have fat fingers tonight. Sorry. Come on. All right, well, just for the sake of now, I'm going to, I bring in a die and I put it maybe here. And then I bring in another die and I put it here. And just to get a little practice, this is where I've used the table so that kids can share it with me. Say we're doing dividing by 10, just to notice what's happening to the digit. The students will record, so they'll take their die and they'll spin it, they'll roll it. And with the die, you can decide which ones you want it to, and that will be their first digit, so they'll record it. And then they can record their second digit, and that is here. And you can put more die if you want. And then they would have to, in my classroom, they would have to build it. And then they would have to show it. So what might that look like? I'm just going to delete all this here. They would build that. They would show. So I would come back here and I would grab, if let's say this is my tens and this is my ones, and what would happen when I would divide this number by 10. And so I would have to show 2 tens divided by 10 is equal to 2, and I would show what would happen here. Let's move these 4 ones out of the way. And they would say dividing by 10, this would become a 2. So I could show where that 2 lives. So 2 tens divided by 2 tens divided by 10 is equal to 2. And then I could show that those 4 ones as well. And I would break these apart to show what would happen. And then they could extend their chart and they could practice that pattern. So that's where I might use a table. Tonight, my fingers are fat and the table doesn't want to respond to it. But I'm looking at the time. And the table, some extra practice that you could do with the digits there. So thank you for your time tonight. The goal for me was to show how a visual model supports and to maybe give you that aha moment, or maybe you're still thinking about it. Is the decimal point moving? Is the digit moving? What's moving? And how can we support our learners, in visualizing what it means to scale by 10 by 100 or to divide by that power of 10 or 100. If you want to learn more, you can visit us at mathodology.com. Those tasks I saw were taken from the Think Mathematics textbooks that we distribute. And Mark, I'll hand it over to you to wrap up tonight.